Welcome to the First Mold Insights, where we talk about injection molding, rapid tooling, product development, and real world manufacturing insights. Today's topic is top and rear clamp plates in injection molds. Alex, we're talking about the backbone of the mold base today. When we think about the incredible forces an injection mold has to withstand, thousands of pounds of clamping force, what's the very first component that comes to your mind as the primary structural element taking that initial abuse?
Well, Mia, you hit the nail on the head. Right at the top, literally, you've got the top clamp plate. That's the unsung hero, really. It's the essential component sitting there right at the topmost part of the mold, designed specifically to take that clamping force head on.
So it's not just holding the mold in place, it's actively resisting the injection molding machine's force to keep everything from, exploding?
Exactly. It's about resistance, pure and simple. If that plate isn't robust, you're going to have major problems. Its main job is to securely hold the mold, preventing any shifting or misalignment while the plastic's being injected. And you know, that careful clamping is absolutely critical for getting uniform, precise moldings. If your mold moves even a tiny bit, your part quality goes straight out the window.
Huh, interesting. So it's not just a flat piece of metal then. What kind of materials are we talking about for something that needs to be that tough? And does it have other features built in?
Oh no, it's definitely not just a flat piece. We're talking highly durable materials here, typically high-grade steel or aluminum alloys. They've got to provide maximum resistance and longevity. And yeah, it's got features. It's designed with holes for things like guide pins and ejector pins, and sometimes even cooling channels are integrated directly into it. These additions are vital for the smooth operation of all the other mold components, ensuring the whole molding process runs efficiently.
Right. So it's got to be strong, but also precise enough to integrate those other critical elements. What are some of the key design considerations when you're crafting one of these top clamp plates?
Look, the design of this plate is pivotal for the whole mold's success. It's all about balancing a few things. First off, size and shape. It's got to complement the mold's dimensions, offering enough support and, crucially, enduring that substantial clamping force. Then TT, here is the material choice, like we said, high-grade steel or aluminum for their mechanical properties. And structural soundness, it must be robust enough not to warp or bend under all that stress and pressure.
So, thickness, I imagine, plays a huge role in structural soundness. How do you actually determine the right thickness for a top clamp plate? It can't just be arbitrary, can it?
No, not at all arbitrary. Thickness is absolutely critical. It's influenced by a mix of factors. The primary one is the clamping force itself. We calculate that based on the mold's projected area and the desired injection pressure. That calculation directly impacts how thick the plate needs to be to resist bending or distortion. Then you've got the mold's size and weight. Bigger, heavier molds? They're going to need thicker plates for adequate support. And the material you're molding also plays a part. More robust plastics might need thicker plates to withstand higher pressures.
So, a lot of engineering goes into it, not just guesswork. Do you ever use tools like FEA for this?
Yeah, actually, that's where structural analysis, like finite element analysis or FEA, comes in. Engineers use it to pinpoint that ideal thickness, making sure it's robust enough for efficient and reliable mold operation, even with safety margins built in for unforeseen forces. You don't want to undersize this component, ever.
That makes sense. Once it's designed and in production, what about maintenance? What's involved in keeping a top clamp plate in good shape?
Maintenance is key, Mia, for optimal performance and longevity. You start with regular cleaning to get rid of any debris, dirt, or plastic residues. Then, lubrication. A light coat of lubricant on moving parts like guide pins that decreases friction and wear, keeping things smooth. Inspection is huge. You're looking for any signs of damage, cracks, wear, corrosion, anything that could impact its function. And if you see something, you address it quickly.
So, proactive checks are essential.
Absolutely. You've also got to ensure the fasteners and bolts are secure, maintaining the clamping force, and that the plate is correctly aligned. Preventative measures are just as important. Avoid overloading the mold, stick to the right injection pressures and speeds, operate within parameters. And proper operator training is crucial. We also document everything: cleaning, lubrication, inspections, any repairs. Those records are invaluable for tracking history and planning future upkeep.
That's a comprehensive approach. Okay, so we've talked a lot about the top clamp plate. But a mold has two halves. How does the other side, the rear clamp plate, complement all of this? What's its crucial role?
Right. So the rear clamp plate, sometimes called the bottom clamp plate, it works in harmony with the top plate. While the top plate is taking that initial clamping force from the machine, the rear clamp plate is pivotal for ensuring the mold is correctly aligned and balanced. It helps secure all the mold components in their precise positions.
So it's more about fine-tuning alignment and balance rather than just raw force resistance?
Yeah, precisely. By exerting force together with the top clamp plate, it guarantees the mold halves stay perfectly aligned, avoiding any shifts or movements during injection. This accuracy is vital for consistent, precise molding outcomes. And it's also about overall balance. It distributes the clamping force evenly across the mold, preventing stress concentrations or uneven pressure, which could compromise part quality. That even distribution is essential for consistent plastic flow, leading to superior final products.
That makes a lot of sense. Does it use the same materials as the top plate, or are there different considerations for the rear?
Good question. The choice of material can vary, but typically it's made from the same material as the mold base, cavities, and cores. That material consistency across these components ensures uniform mechanical properties and thermal expansion characteristics, which contributes to overall mold stability. However, there are cases where it might require a different material to meet specific functional demands or unique operating conditions.
And when it does need something different, what kind of materials are we talking about?
We'd still be looking at high-quality steel alloys, like P20, H13, S13, S33, DH2F, or GS230 These are chosen for their robustness and longevity. The usual workhorses of the mold-making world.
Okay, so similar toughness. Are the design considerations for the rear clamp plate similar to the top, or are there unique aspects?
They share some common ground, but there are definitely unique aspects. Structural integrity is still paramount. Of course, it has to endure clamping forces and support stability without bending, and precision for alignment is key. It needs to be machined to strict dimensional tolerances. But then you also have specific needs like integrating cooling channels or vents. That's vital for heat management and expelling air or gas during molding, preventing issues like warping or trapped air.
Cooling and venting? That's an interesting one for the rear plate.
Yeah, it is. And like the top plate, component integration is their guide pins, ejector pins, other elements. Accessibility for maintenance is also a big one, making sure there are access points for easy part removal or cleaning. And finally, safety and ergonomics. The design should mitigate accident risks, avoiding sharp edges or hazardous protrusions. We're thinking about the operators who interact with these molds every day.
So it's about making sure the mold is robust, precise, and safe to operate.
Exactly. For a product designer, you don't need to specify the exact steel grade for these plates, but you absolutely need to understand their fundamental role in ensuring mold stability, part quality, and overall production efficiency. They might seem like just plates, but they're doing a lot of heavy lifting, literally.
Thanks for tuning in. For more manufacturing resources or custom part production services, visit firstmold.com. We'll see you next time.